Sequencing. The student will find and evaluate an algebraic expression to determine any term in an arithmetic sequence with a constant rate of change. Arithmetic sequences can be a lot of fun. It's like solving a puzzle. So you're trying to find out what the rule is, what is being done every time to get the next number in the sequence. In order to do this, you'll need to know what the constant difference is between the terms. And arithmetic sequences always have a constant difference between the terms. So let's look at the first one. The difference between 1 and 5 is 4. From 5 to 9 is 4. 9 to 13 is 4. And 13 to 17 is 4. That's called the constant difference. How about the next sequence? From 22 to 17, you're going down by how many? 5. From 17 to 12, down by 5. And you're consistently going down by 5. So your constant difference here would be a negative 5. This will be an important part to solving the puzzle. There are 5 steps that you can use to find a pattern rule. Please put these 5 steps in your notes, and then we'll have a look at some examples. Here we have our first example. We'll start with step 1, number the terms. What do I mean by number the terms? You're simply going to place a number above each number in the pattern that's given to you, indicating what place it holds in the sequence. So this is 4 is the first number, 12 is the second number, 20 is the third number, and 28 is the fourth number. So you're simply numbering 1, 2, 3, 4. That's step 1. Step 2, you're going to find the constant difference between the terms. So what's the difference from 4 to 12? It's going up by 8. From 12 to 20 is up by 8. And from 20 to 28, it goes up by 8. So we've completed steps 1 and 2. And now for step 3. We're going to multiply the term number by the constant difference. So earlier we numbered them 1, 2, 3, and 4. And now we're going to multiply that by the constant difference, which is 8. Because if it goes up by 8 every single time, then it makes sense if you wanted to find a certain number's term, you would multiply by the term number, because that's how many times it increased by 8. So we have 1, 2, 3, and 4. And each time we're going to multiply by 8. So times 8, times 8, times 8, and times 8. When we do that, we'll come up with a value. 8, 16, 24, and 32. Now our hope was to be able to get the value of each term. But you can see we were not successful. 8 is not 4, 16 is not 12, 24 is not 20, and 32 is not 28. It is not the first, second, third, and fourth term. So there's still another step that we have to complete. In order to get the number that we were hoping to get, we still have another step to complete. Here we have our first, second, third, and fourth terms. We took those and we multiplied them by the constant difference of 8. And we got a value. Our goal was to get the value in that position. So 4, 12, 20, and 28. In order to get to that value, from the value that we obtained originally, we're going to either add or subtract. So we had hoped to get 4, but what we actually got was 8. What do we need to do to get from 8 down to 4? Well, we're going down, so we're going to subtract. And how many will we subtract? 4. To get from 16 to 12, we need to subtract 4. From 24 to 20, we need to subtract 4. And from 32 to 28, we need to subtract 4. So here, each time, we're consistently subtracting 4. And now we can finally solve the puzzle. We're going to create a pattern rule that would help us to get any term. So we could get the 100th term if we wanted to, and we wouldn't have to list out every single number. So let's make our rule. We started with the term number, and we multiplied it by the constant difference of 8. And then we determined we were not where we needed to be. And what did we actually have to do to get there? We had to subtract 4. So we have 3 main components here. We have our term number times a constant of 8, and then we have to subtract 4. And that gives us our term number every time. Our term value every time. Our term number is 1, 2, 3, and 4. The term value is 4, 12, 20, and 28. So let's make our rule. Every time we multiply the constant difference of 8 times the term number, which is the number's position in the sequence, and then we subtract 4. And every time, that gives us the value of the term. So let's just have a look at this really quickly. Make sure that you understand. We have 8 times, let's say, the 4th position, okay, times 4. And then we subtract 4. 8 times 4 is 32, and 32 minus 4 is 28. So as you can see, if you put a 4 in for the value of n, you get out the 28 that goes along with it. So we've done a good job in creating our rule. Alright, so I want you to write in a complete sentence, answer this question: how would you use the pattern rule 8n minus 4 to find the 20th term in the sequence? Write out your sentence and then check and see if it matches closely with mine. Okay, here's my sentence. I would multiply 20 by the constant difference, which is 8, and then subtract 4. Yours could say, I would multiply 8 by 20 and then subtract 4. Or it could say anything similar. The idea is that you need to multiply 20 by the 8, and then you need to subtract 4. Let's find another pattern rule. Remember step 1, you're going to number the terms 1, 2, 3, and 4. Step 2, we'll find the constant difference. So it goes up by 3, up by 3, up by 3. Then we list our term numbers 1, 2, 3, and 4. And we multiply by the constant difference. Times 3, times 3, times 3, times 3. And you'll find out what value that gives you. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. And we need to see what we still need to do to get each value. So for the first term, we're trying to get a 4. Second term, we're trying to get a 7. The third term, a 10. And the fourth term, a 13. What do I need to do to get from the 3 up to the 4? I need to add 1. To get from the 6 to the 7, 9 to 10, and 12 to 13 each time, we need to add 1. So we're ready for our rule. First we multiply 3 times the term number, and finally we add 1. So we have our constant difference of 3 times the number's position in the sequence. Excuse me, I got the wrong color there. Times the number's position in the sequence. and then finally you add 1. Let's use this rule now to find out what the 100th number in the sequence would be. It's much quicker this way than if you had to write out a gap of 3 100 times. This will get you there much more quickly. So we have 3n plus 1 as our rule. And if we want to find the 100th term in the sequence, we would substitute 100 for n, multiply, and then add. So 300, 3 times 100 would give us 300, plus 1 would give us 301. So we know that the 100th term in the sequence would be 301. Let's have a look at a different type of example. Here we have a chart that lists 4 terms and their term numbers. So step 1 is already complete for us. The terms have been numbered. Step 2, we'll find the constant difference. How much does it go up by each time? 4. What do we do with the constant difference in the term number? We multiply them. 1, 2, 3, and 4. Each time we're going to multiply by 4. What value does that give us? Gives me 4, 8, 12, and 16. Are those the values that I want to get? I want to get 3, 7, 11, and 15. So I didn't get the right number. What do I still need to do to get it? Am I going to add or subtract? I need to go down, so I'll be subtracting, and from 4 to 3, I need to subtract 1. From 8 to 7, subtract 1. From 12 to 11, subtract 1. And from 16 to 15, I'll subtract 1. So now we can create our pattern rule. First, we multiply by 4, and then we subtract 1. So our rule would be the constant difference of 4 times the term number, and then subtract 1. So we're going to match this to an answer choice. And you will see it matches answer choice D. So D would be the correct answer. Now I'd like you to try it on your own. Using the notes that you've taken thus far, I want you to see if you can solve this one. So pause the video and then check and see if you got the right answer. Alright, so we have our term numbers 1, 2, 3, and 4 lined up. Our constant difference is 5, so we multiply each one by 5. We get 5, 10, 15, and 20. We are looking to get 1, 6, 11, and 16. What do we need to do to get from 5 down to 1? Subtract 4. From 10 to 6, subtract 4, and each time you're subtracting 4. So our pattern rule, we're multiplying by 5 and then subtracting 4. What are we multiplying by 5? Our term number, which we'll call n, and then we're subtracting 4. So if you answered B, you got it right. Good job. Alright, how about this one? We're given the pattern rule, 3n plus 2, and we need to choose which sequence matches it. We know that the 3 represents what? 3 represents the constant difference. So we're looking for an answer choice that will most certainly have a constant difference of 3. So from 1 to 5, what's the difference? 4. And then from 5 to 8 is 3. And from 8 to 11 would be 3. So this is actually not a sequence at all. It's not consistent. So it's not answer choice A. From 5 to 7, a difference of 2. From 7 to 10, a difference of 3. And from 10 to 13, a difference of 3. Again, this one is not a sequence, an arithmetic sequence, because it does not have a constant difference. Now, from 5 to 8 is 3, 8 to 11 is 3, and 11 to 14 is 3. The next one, 5 to 8 is 3, 8 to 12 is 4, and 12 to 15 is 3. So again, D would not qualify as an arithmetic sequence, so our answer choice will be C. Now they won't always work out that easily, so let's have a look at another way to do it. Another way to do this is to number the terms. 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. And 1, 2, 3, and 4. And what I like to do is take the largest term, 4, and substitute in 4 for the n. So where you have 3n plus 2, I'm taking the fourth position, so I'm going to multiply 3 times 4. 3 times 4 is 12, and 12 plus 2 is 14. And I can see A does not have 14. B does not have 14 for the fourth position. C does, and D does not. So the correct answer would be C. So there are two different ways that you could go about answering that question. Alright, let's get some more practice finding pattern rules. Here, we have a pattern that's going down. So this is a little different than the ones we've looked at. We'll start by numbering our terms. 1, 2, 3, and 4. Then we'll find our constant difference. From 18 to 14 is minus 4. 14 to 10, minus 4. And 10 to 6, minus 4. So we'll take our term number, multiply it by negative 4, and let's see what we get. 1 times negative 4 is negative 4. 2 times 4 is 8. A positive times a negative is a negative. 3 times 4 is 12. A positive times a negative is a negative. And 4 times 4 is 16. Positive times a negative is a negative. Now those aren't the numbers we were looking for. We were looking for 18, 14, 10, and 6. So we're pretty far off. What do we need to do to get to the numbers that we intended to get to? What is the difference between negative 16 and 6? Well, to get from negative 16 up to 0, that would be 16, and to get from 0 to 6 would be another 6. And 16 plus 6 would give us 22. So we see that we need to add 22 here. From negative 12 to 0 is 12, and from 0 to 10 is another 10. 12 plus 10 would give us 22. So you can see each time we're adding 22. So these are a little bit trickier because you do need to account for the difference between the negative number and 0, and then from 0 to the positive number. So let's determine our rule. We multiplied first by a negative 4, and then we added 22. So our rule would be negative 4 times the term number plus 22. Now we'll take our pattern rule and determine what would be the 100th term. So to find the 100th number in the sequence, we'll substitute 100 for n. So we have negative 4 times 100 plus 22. Negative 4 times 100 would give us negative 400. And then when we add 22, we have 400 on the negative side, 22 on the positive side. And what is the difference? 400 minus 22 would give us 378. And we have more negative, so that will be negative 378 would be the 100th term in the sequence. Okay, try this one. Find the pattern rule and see if you do it right. Pause the video. Alright, how did you do? First you would multiply by negative 3 because that's the constant difference. And then you're 79 short each time, so you need to add 79. So the rule is negative 3 times the term number plus 79. Now see if you can solve for the 15th term. So pause and see how you do. Did you get 34? If you did, give yourself a pat on the back. Good job. When you substitute 15 for the term number, that gives you negative 45. And when you add 79, that will give you a positive 34.